Reciprocal identities or reciprocal trig functions. Reciprocal means taking a fraction and flipping it. So what would be the reciprocal of 2? 1/2. What would be the reciprocal of 2/5? 5/2. Okay, that's what a reciprocal is. It's when you flip a fraction. Okay, so here are what I call the original trig statements. The original trig ratios. They're sine of theta, cosine of theta, tangent of theta. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We memorize it however we want. It's SOHCAHTOA if you like that. Today we're going to be learning reciprocal, not inverse. There's a difference. Reciprocal ratios. So here's what we've got to kind of do here. I actually am re-videoing this year because I don't think I showed this last year and I think I should. So cosecant, everybody write that down. Cosecant of theta, what is that? Well, I'm telling you, that is 1 divided by sine of theta. It's the reciprocal of sine. Cosecant is 1 over sine. So you can also say this, look, sine of theta is equal to 1 over cosecant theta. So you can reciprocate these and they're equivalent.
Are you videoing that?
Yeah. So I'm just showing you why cosecant is what it is. So let's just look at this. And the reason I bring this up is for the future. Okay, so everybody think about this. Well, then what would be the statement here? So write this down. Cosecant theta equals 1 over sine. Isn't sine opposite over hypotenuse? So we have 1 divided by opposite over hypotenuse. Isn't that what sine is? Everyone, you with me? Which we know that's really, watch, dividing fractions can be hard for people. So I recommend calling that 1 a 1 divided by 1 divided by opposite over hypotenuse so that you can get your placeholders right. I actually didn't even start doing that till calculus. And I started doing that when I was missing easy points by having to divide fractions and I was putting it in the wrong spot. So we know dividing fractions is easy as pi, flip the second and multiply. So we're going to flip the second and multiply. So it's h over o. So there we go. Cosecant theta is h over o. Now, am I going to do the work like that every time? No. You know what I'm going to do? Watch. I'm going to go like this. Sine of theta equals opposite over hypotenuse. And then I'm going to go cosecant theta equals hypotenuse over opposite. You know what I mean? Why would I every single time show my work on how I'm getting h over o? Do you guys see what I'm saying? But I wanted to show it this time of like why it's that. And it's kind of nice in the future to know that cosecant can be written as 1 over sine. So if you see 1 over sine, what could you write it as if you want?
H over O.
Because cosecant.
Oh, yeah.
Like you can switch those back and forth. They're equal.
CSC?
Yes, that's just new today. It's called a reciprocal. It's a reciprocal trig function. Okay, so now let's do cosine. So everybody, this is new to you. Secant theta is equal to 1 over cosine. They're reciprocals. So you can also say this. Cosine of theta is equal to 1 over secant. These are things that can be said about each other. These are equivalent. They're reciprocals. So this is new to you. Secant theta. So once again, I'm just showing it this one time. So if secant theta is 1 over cosine, isn't it 1 divided by, what is cosine's statement? Adjacent over hypotenuse.
Wait, are you saying secant or?
Yeah. Yeah, secant. Secant. So it's just gonna take some memorization. It's just like it's like a title, I guess. So what does secant mean? It means reciprocal cosine. Why did they give it the name secant? I have no idea. Okay. So then from here, if we flip that, won't that be h over a? Yes? We flip the second and multiply. So once again, though, I'm only showing my work this time so you can see. But look, when I do it in the future, I say cosine is adjacent. Oh, heck, another hour. Okay, adjacent over hypotenuse. And then I say, and then secant is its reciprocal. So that would be h over a. I don't go through the BS every time. Okay. So then tangent, everyone. Tangent of theta is equal to 1 over cotangent of theta. And vice versa, you can say cotangent of theta is equal to 1 over tangent of theta. They're reciprocals. Cotangent is new to us today, cotangent. So once again, you would say that is 1 over, isn't tangent opposite over adjacent? So if we flip and multiply, I'm just showing my work this time. we now can say that cotangent of theta is A over O. Once again, though, this is what I do. I don't go through the work every time. I go like this. So if I have a right triangle and I have a theta, we know we can draw theta anywhere but the 90 degrees. I then go through and state the following. I always go sine, cosine, tangent. I write down those ratios. I then write down cosecant, secant, cotangent. You have to remember what one goes with what one. And then I literally just reciprocate. H over O, reciprocate. H over A, reciprocate. A over O. Now we have 4 of them. I only use the originals when solving right triangles. I don't use these for that purpose. So like, what could these be used for? Well, you're going to see today. Okay. So I need to point something out as we memorize this, okay? So listen so you're not confused at what I'm saying. See how this is an S and this is an S down here? Yeah? A lot of people will put sine with secant on accident because they say S will go with S, but that's incorrect. S goes with C, so make sure you don't put the S's together. See, it goes S goes with C, and then C goes with S. S goes with C, C goes with S. Okay, and then tangent and cotangent, they have the same like name almost, so it's easy to remember that one. All right, so look at what this asks. It asks you to calculate cosecant theta. We know there's a difference between finding theta and finding a statement. This says find the cosecant of theta. So this would take memorization. You'd go, okay, so is the reciprocal of cosecant. True? Everyone? S and C. Do you guys see I'm using my trick? S and C, yes? So you'd say sine is opposite over hypotenuse. So what's this one? H over A. So that's where you'd start. Cosecant is H over A. Look at the triangle. What? Whoa, why did I do A? H over O. Why am I saying A? I don't know. My bad. So now from here you would say, okay, what's H? Look at your theta. What is H? Hypotenuse. What's the hypotenuse? 5. What's the opposite? 4. So the answer is cosecant theta is equal to 5/4. We didn't find theta. We didn't find a side length. We found a statement. Cosecant of theta is 5/4. It's that ratio. It's that simple. Okay, secant of theta is a statement. You would say, okay, secant, what's that the reciprocal of? So or ka or toa? Ka. So that was A over H normally. So won't it be H over A? So H is 8. Adjacent is, they gave it to us, didn't they? Isn't this opposite? Okay, well, we didn't need opposite, and it wasn't given, so they were being really nice to us. H is 8. Adjacent is 4, so what would we get? 2. I just need to be very clear. You didn't solve anything except for a ratio. You said secant is 2. So now what if they then said, okay, so then what's the cosine? That should be easy. What do? Take your answer and do what with it? Flip it. So what would that be? 1/2. Yeah, just pointing out. Okay, cool. All right, so looking at this one, this is homework problem number 1. It says find the secant. So once again, you're going to go, is it so or ka or toa's reciprocal? Not inverse. Inverse is not the same thing as reciprocal. It's a reciprocal. It goes with ka. True? Adjacent over hypotenuse is ka, so we're going to do H over A. What's our hypotenuse? 6 square roots of 13. You're right. That's always across from the 90 degrees. Go to theta, and isn't this opposite? Because it's straight across, everyone. Yeah. And isn't this adjacent then? Yes. So then it would be that, which then simplifies. Why can we divide out 6 and 12? Because it's across a multiplication sign, not an addition or subtraction sign. So this becomes 1/2. So root 13 over 2. Yes. Okay, if you're sure. Happy to answer any questions. Okay, so again, look at this one. This is homework problem number 6.
Pardon the interruption. Can I get Nathan Johnson for checkout?
Sure. SOHCAHTOA. Once again, you'd say it's the reciprocal of ka. Normally it's adjacent over hypotenuse, so we need to do hypotenuse over adjacent. Look They gave us the hypotenuse. They gave us the opposite. Uh-oh. Well, then they didn't give us adjacent. That doesn't mean we can't find it. Isn't there 2 side lengths of a right triangle? Then you can find the third by Pythagorean theorem. A squared plus B squared equals hypotenuse squared. So you would do 4 squared plus B squared equals 5 squared. 16 plus B squared equals 25. Subtract 16. B squared equals 9. Square root. B is equal to plus and minus 3. In the context of this problem, we would throw out negative 3. We would just put positive 3. All right, now we can answer their question. Our hypotenuse was 5. Our adjacent was 3. So secant of theta came out to be 5/3. That is the ratio. We haven't found a side length. We haven't found theta. We've just found a statement, a ratio. Questions on that one? Okay, so pretty easy. All right, now they're going to ask you just to calculate sine of 12 degrees. So literally we know sine, cosine, tangent are just calculations. They're numbers. So let's just go plug it into our calculator. Make sure your calculator's in degree mode. So everybody hit mode on your calculator. And then go down to radian versus degrees and make sure you're highlighted on degrees and then hit second quit and then type in sine of 12. Let's round to 2 decimal places. I'm getting 0.21. How about you? Let's do cosine of 22. That's 0.93. I'm rounding to 2 decimal places. Tan of 10. I'm just typing it in. 0.18. Now, how do you type in then? What if I ask you to do, watch, what if I ask you to calculate cosecant of 12? Well, there's not a cosecant button on the calculator. And don't say inverse, because that's not the same thing. Yeah, you just say 1 divided by sine of 12. Exactly. So you would do 1 divided by sine of 12 in your calculator. That would give you 4.8. I'm rounding to 2 decimal places, so I guess 4.81. So if they said secant of 22, what would you type into your calculator? 1 over cosine of 22. 1 divided by cosine of 22. There's a difference between inverse and reciprocal. Okay, so I think we get the picture with that. So this is homework problem number 7. It says cosine of 13. I don't even know why that's that easy. It's 0.97. Okay. All right, cool. Now this is where you need to lock in if you have zoned out, because these, I really find them fun. You have to make sure you don't overcomplicate them or I don't know. You just got to find a balance in your head. So let me tell you something, okay? We're simplifying a statement. So we're taking this and we're going to simplify this statement down. So the question is, what does this simplify to be? So it's like, well, how do you know when you're done? Well, you're going to try to have it only be one term. This is one term, by the way. Terms are separated by plus or minus signs. So you're going to try to only have one term, and you don't want any fractions in your final answer. Now, there's 2 ways to do it. I'm going to show both ways because some of you are going to like the first way and some of you are going to like the second way. So here's way number 1. You can simplify this statement by setting up what these ratios are. So what is cosine? As in, let's write down our ratio so we don't get confused. There's so, ka, toa. Okay, so I'm going to then go like this, okay? Sine of theta, cosine of theta, tangent of theta equals opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Then we're going to write down their reciprocals. So I'm going to go like this and erase that because I need room. I like to write them next to each other. Cosecant theta is h over o, true? Secant theta is h over a. And cotan of theta is a over o. Okay, so what you can do is on way number 1, you can write down these as ratios instead of what they currently are. So what is cosine as a ratio? A over h, guys. You're choosing to write it instead as its ratio. They're equal, aren't they, everyone? Then we're timesing that by secant. What is secant? H over A. Now from here, you're simplifying. This is basic algebra. It's not a trick. What's on top? A. What's on bottom? A. What's on top? H. What's on bottom? H. So what does that become?
Nothing.
1. So that simplifies to be 1. Some people like to do it that way, but some people would rather do it way number 2. So watch. If you don't like that, then do it like this. Go like this. I actually do it a lot of times this way I'm about to show you. So what I do is, this is kind of how I start. I say, okay, I'm going to leave any of the originals alone. Isn't cosine an original? Sine, cosine, tangent are the 3 originals. Do you guys see what I'm saying? Anything else, I'm going to write what it's equal to. What does secant really mean? 1 over cosine. True? So how do we multiply fractions? Straight across. So what are we getting here? Cosine theta over cosine theta, which is 1. We get the same answer. It's just, what do you like better? What do you want to do? Okay. Okay, let's do another one. Okay, once again, let's do it both ways. So cosine, what is that? A over H, and then we're timesing that to cosecant. What is that one? It is? No, it's not. Isn't it the reciprocal of sine? This one is the reciprocal of sine. Wasn't sine opposite over hypotenuse? So this would be actually H over O. True? Are you guys with me? So then what divides out? The H's. So what does that leave me with? A over O. You can't leave your answer as A over O. That was a trick. You're using ratios to write answers. So now what is A over O equal to? So, Toa. True? Whoa. So what is it? Is it A over O? So it's not tangent, but it's cotangent. So the final answer would be cotangent of theta. So if you do it this way, you have to then transfer your final answer back to which ratio is it? Is it sine? Is it cosine? Is it tangent? Is it secant, cosecant, or cotangent? Okay, let's do it the other way. Like I said, you might not like that way, because then, like, if you do it the way I do it most of the time, you don't have to then transfer your answer back. So I'm erasing this so I have room to write. Okay, this is what I would do. This is just, oh, yeah, I guess, well, you have to have more information to do this way. But this is good. This is good to see it. So here we go, everyone. So wouldn't you agree that let's just leave cosine alone? I like to leave my originals alone. What is cosecant? 1 over sine theta, true? So now we have cosine theta divided by sine of theta. Now how are you going to know what that is? Well, I have to give you more information, which was going to come up in the next lesson. So let's just bring it up now. I'm going to give you another true statement. Ready? Let's write it down. Tangent of theta can be written as 1 over cotangent. We already know that one, true? Another one, if you want, is tangent of theta is actually sine of theta divided by cosine of theta. They are equivalent. So which one's better? If you see sine divided by cosine, what would be better? Tangent. Why? Because it doesn't have fractions. Do you guys see what I'm saying? Fractions are less desirable than no fractions. So if you see sine over cosine, you'd say tangent. So, okay, cool. Well then, let's reciprocate that. Then what would be cotangent of theta? Cosine over... I'm reciprocating these over sine. So now you wouldn't have known that until I gave you this information. Now I did. You'd have to memorize tangent is sine over cosine. So now cotangent is cosine over sine. So when we see cosine over sine, we'd say, oh, that is cotangent of theta. So we got cotangent either way. It just takes some practice and some confidence, and you do have to know you have to know things. It takes some memorization. Okay, so let's do this one. Do you want to do it the ratio way? Let's do it both ways. What's cosecant? So it's the reciprocal of that? So isn't this h over o? Okay, cotangent. Most students, when they start this, like this method better. Tangent is opposite over adjacent. So don't we need to say adjacent over opposite? So then you would say dividing fractions is easy as pi. Flip the second fraction and multiply. So what would this become? Over a? So now what happens? Good. It turns into HA over A. You can't leave that as your answer. What is HA equivalent to? We know it goes with this one, but it's not A over H. So it's secant theta. So you'd say that is secant theta. How do I know it's as simplified as it gets? There's no fractions. There's only one term. There's only one statement, too. So look, here's the purpose of this, guys. It really is, okay, so here's what I want to show you, okay? So let me explain. What's the purpose of this? So in the future, in your future lives, you're going to see this, and you're going to be asked to do a calculation with that. And it would take a really long, hard time to do it if you did it as is. If you recognized, oh, you know what? That is actually just secant theta. Now you're doing calculus on this. There's no division sign. It's just one statement. It's going to go much easier and quicker. So right now you're not seeing the purpose of this, but in the future, in your future lives, it would be like, oh, are you good at recognizing this written as a better format so that your life is easier moving forward? Do you guys see my point? Okay, so it's just getting good at practicing simplifying stuff and thinking of, how could I rewrite this? Okay, cool. Let's look at this one. Don't let it intimidate. Oh, wait, do you want to do it the other way? In case you like the other way, because I'm telling you, sometimes it is nice to not have a bunch of H and A and O's and whatever going on. Okay, so let me do it the other way now. You might change your mind. Okay, so don't get overwhelmed by this. It just takes time and practice. Here's what I want to tell you though. You literally can't go wrong. As long as you don't write down a wrong ratio, you literally can't mess it up. So it's trying to reconnect here. The internet must have had an issue. Come on, come on. So that's the thing, like, I don't let these, the only difference between you and I is I don't let these stress me out as I go. Like, I'm like, okay, I'll write this down, kind of weird. Like, what goes next? Oh, I need to flip and multiply. Oh, what is that? Oh, so, like, it just doesn't stress me out. You just can't let it stress you out as you write down all this stuff. Okay, so this is the other way. What is cosecant equivalent to? It's not an original, so I guess I'll rewrite it. What is cosecant equal to? 1 over sine of theta. Good. Then we have a divide. What's cotangent equal to? 1 over tangent of theta. True? Okay. Now, if I wanted, could I choose a different statement? Let's see if we could. That's 1 over sine of theta divided by, what is cotangent also equal to? If you want to do 1 over tangent, cool. If you want to do something else, can you? Yes. So let me remind you of something. Isn't it true that tangent of theta can be written as sine of theta over cosine? So what is cotangent of theta equal to? Cosine over sine. So would I choose that or would I choose that?
I don't know.
Here's what you know. Look what you see on top. Are you seeing tangents or sines? You're seeing sines. So wouldn't it be wiser to choose this? Sines can simplify with sines, right? So you're like, this might be a wiser choice. So cosine theta over sine of theta. So now watch. Dividing fractions is easy as pi. Flip this fraction and multiply. So that's sine over cosine. You guys understand that to do this, you'd have to have these memorized, right? You'd have to know that tangent sine over cosine. You guys understand that, right? That's not something you just know. I'm telling you, you'd have to memorize it. Which I saw cotangent, so I was like, I got to do the reciprocal of that. Okay. All right, so now from here, what's happening? The signs will cancel. So that leaves me with 1 over cosine. Now look, 1 over cosine is not an answer I should be circling. Why? Because it has fractions. What is 1 over cosine as not a fraction? Secant. Right, everyone?
Yeah.
So that would be your final answer, would be secant. Because then it has no fractions. So there always is those kids that will circle this on the test, and I'm like, oh, bummer, they were so close. Like, you should never have fractions in your final answer. You should always then convert it to its equivalent statement. Okay, again, look at this one. Wait, how are you guys liking it with the A's and H's and O's?
Yeah, I like that way.
Okay, like I said, push yourselves to practice both, really. Okay, what's sine? Sine. I personally I don't just change everything. That's where these kids get in trouble. They just start changing everything. Like, you gotta have a starting point. Like, I like the originals, so I keep them. So sine I leave alone. So write it, sine of theta, and I'm gonna cross it out. Okay, what is secant? I'm gonna do the other way first. What is secant? Yep, 1 over cosine. True? Everyone? Are you guys with me? Then I have divided by tan. We can do lots of things with tan. Let's review together in our brain. We could call it 1 over cotangent. Look at the top. Would that even help us? No. So what else can we call tangent? Sine over cosine. We had to memorize that. Tangent, if you want, can be written as sine over cosine. And I say I want. Why? Because on top I'm seeing sines and cosines. Sines and cosines simplify with sines and cosines. So I'd say tangent, I'm rewriting this as sine over cosine. Now don't go yet. Don't go anywhere yet. What you're going to do is say, what is the top really? It's just multiplying straight across fractions. So we have sine theta divided by cosine theta, don't we? Divided by sine theta over cosine theta. True? Why don't you guys get that? Look, times straight across. So sine over cosine. And then this is sine over cosine. Same thing. I just am not writing it all fractiony. Yes?
Where did that fraction come from? Like this
Which
one and the cosine.
We have to memorize the tangent. So there's lots of things you can write tangent as. We said, I erased it, but we said, oh, can't we write tangent as 1 over cotangent?
I'm talking about the one right above.
This?
Sine, the one above.
Oh, this?
Yeah, is that from?
That was from this sign.
Oh,
And then secant was 1 over cosine.
oh,
So there's just, I keep all my originals alone. Do you see what I'm saying by originals? Sine, cosine, tangent are originals. Except tangent I decided to switch. Why? Because I'm seeing sines and cosines on top. Okay, do I need to start over completely from the beginning? Okay, you guys are going to lock in, right? Yeah? Okay, again. You guys, it's just really keeping everything straight. Okay, so I see this sign. Do you all see it? I choose not to switch it. Could I? Sure. But I'm going to choose to not switch it because it's an original. So I write sine of theta. Now keep everything straight. I've just rewritten this. Do you guys understand that? I see secant and say that's not an original. So what am I going to rewrite it as? Isn't this right here a time sign, my friends? So I'm going to put a time sign. So that would be 1 over cosine. This is just the top. Is everyone with me? So what is the top? Let's do it right now. What is the top? Sine theta over cosine theta. How did he know that? Because he knows how to multiply fractions. We multiply fractions straight across. Do you guys understand how the top becomes sine over cosine? That's just the top. I repeat, that is just the top. So as of right now, I have this. Divided by tan. I have not done anything besides the top. Is everyone with me? Then you'd say, okay, this must simplify more. Obviously, look, that's nasty. That's ugly. We should have a pretty statement in the end. So let's write tangent as something useful to us. Now, tangent can be written, it's a special one. It can be written as 1 over cotangent, but there's something else. We're memorizing it. Tangent, if you want, can be written as sine of theta over cosine of theta. We are not getting into why today. I'm telling you, it can be written as that. So let's choose that. Why do I decide to choose that? Because isn't that going to be looking similar to that? Things will be simplifying. So we would say, okay, so we still have sine theta divided by cosine theta. And what are we writing tangent as? Sine of theta over cosine of theta. Okay, now I can see what's happening. That's your statement. What's something divided by itself? 1. So this simplifies to be 1. Something divided by itself is 1. Yeah? Okay. Let's do it with the A's and H's then. What is sine?
Sine is over H.
Opposite over hypotenuse. What's secant? I'm going to write down or else I'm going to get confused. SOHCAHTOA. So sine was opposite over hypotenuse. So then you guys understand that secant is H over A. Yeah? Then divided by tan. O over A. Okay. Do you guys see how we've just written these as O's and H's and A's? Now you'd say, okay, let's figure out the top first. So we multiply, the H's divide out. So we have O over A divided by O over A, which is 1. It's only easier sometimes. That's why I'm showing both. It really is. For these basic ones, yes. But there's going to be some in the future where, look, let me explain why I'm showing both. Because you guys are probably thinking I'm Mr. Jones II, showing unnecessary things. But that's not what I'm trying to do here. So sine squared theta plus cosine squared theta equals 1. We're learning that next time. I'm just trying to make a point here. Do you really want to have to write H over A squared plus, you know what I mean, plus A over H squared equals 1, and then you want to have to get a common denominator? It's just, yeah, it's going to be nasty. So instead, if you just don't have to write out A's and H's, that's going to be easier to not do that. So that's why it's just not always easier. All right, let's do number 11. Try it by yourself. What does this simplify to be? Literally, you can't go wrong. Like, as long as you don't write down an untrue ratio, you cannot mess it up. Now remember, you don't just switch everything. Start with the originals and leave them alone. Anyone else getting 1? I'm just hearing 1. I'm not saying it's right. I'm saying check mark as in I heard a few people say 1. Anyone else getting 1? How did you do it? What'd you do? Just so I know. Anyone? You said A over 8? A over... Wait, what'd you say?
I just kind of wrote it out, like I did O over A and then
Over A times?
A over O, and then I just like kind of like crossed them out.
Yep, that works. Watch. I did it like this. I said tangent of theta is tangent. Cotangent is 1 over tan. Isn't cotangent 1 over tan? So then isn't tangent and tangent dividing out, leaving you with 1? 2 ways to get the correct answer. Okay, let's do number 13. Ready, go. 13 on the homework. You can only get good at these with practice because you learn, like, oh, I can't go wrong. I just can't write down an untrue ratio.
I got sine.
Okay, I'll write that over in the corner.
I did them. How did you do them so fast? No, I did them before while she was showing the different.
It doesn't matter how fast you are at these. You can be slow at these and still get them right. And the answer, I mean, the point is, do you get them right?
Yeah.
Is everyone getting what? Sine?
Yeah.
How'd you guys do it?
I did it the O.
You did it the AOH way? So A over H times O over
Over A. Over A.
H over what?
No, it's O over A. Sorry.
No, it's fine.
Which is O over A.
So you're saying cosine is A over H.
Yeah.
Tangent is O over A. Okay, then they said these A's divide out, leaving me with O over H, which is equivalent to sine. Yes. Watch. Watch how much quicker it would have been if you would have done it like this. Not that there's a wrong way. There's not. I'm just proving there is validity to the other way. I leave cosine alone. How could I write tangent? 1 over cotangent. That's not helpful. How else can I write tangent? Sine of theta over cosine of theta. So what happens? The cosines divide out and I get sine of theta. Admit, that was easier that time. All right. It doesn't matter how you do it. Okay, this is 18 from the homework. Let's go. Everybody go. Try it by yourself. You literally can't go wrong as long as you don't write down an untrue ratio. See if you can get it. Interesting. Everyone do it, and then if you're getting stuck somewhere, come say like, okay, from here, what would you do if it were you? Because I can give you a hint. Oh, well, let's maybe get rid of the fraction now, or... You guys are getting it way quick. Okay, cool. Go slow, go slow. Some people went ahead, and so we can't count against them, which is fine. I'm just saying we can't count our time against them.
We're getting, yes.
Oh yeah.
You know what? Guys, this is so easy. Just like forget about everything you learned before.
Wait, what do I do once I get
Let's do number 18.
This takes work. Baby, you have to log out.
This is actually going to be a decent portion of the test. These simplifying statements like this. Are you getting one? How are you guys doing it? The H over A, O over H way?
I like the
So if you did it that way, you would have said opposite over hypotenuse divided by adjacent over hypotenuse times opposite over adjacent. Oh, AH. My bad. So then these A's divide out. So then you have O over H divided by O over H, which is 1. Okay, let's do it my way, my favorite way. I go like this. Sine of theta divided by cosine of theta, and then that's times tan. I could write tan as 1 over cotan, not helpful. So I'm going to call it sine over cosine, yeah? Yeah? So then we have sine of theta divided by cosine theta, sine theta. Oh wait, the cosines divide out, don't they? So we just have sine divided by sine, which is 1. Okay, now I want to point something out. My friends, my advanced thinkers out there, look, this is for you people that are like the BC calculus students, okay? Kid's gonna go to that after next year. Okay, watch. Advanced thinkers, watch. Could you see this if it were you? This is another way of doing it. Isn't it true that sine over cosine is tan? Yeah. So that would be tangent of theta divided by tangent of theta then.
Oh, so you mentioned 1 again.
Which is 1 again. You cannot go wrong, my friends, as long as you don't write down an untrue ratio. So it doesn't matter how you got there. If you're getting the correct answer of 1, cool. That's what we need. Okay, another one. Ready, go. This is off the homework. I'm not wasting your time. I'm confused why people aren't wanting to get some of these homework ones done. Try it. Give it a try.
Oh my goodness.
Can't go wrong as long as you don't write down an untrue ratio. Give it a try.
Let's just not write the untrue statement. We're gonna write the true statements.
No, you can't. I meant the year after that. Yeah.
Is it a quad something?
You'll know if you're a BC or AB calculus student after next year more accurately.
Square. Is it a quadratic somehow?
No. What? Yeah. AB is Calc 1 and BC is Calc 1 and Calc 2. That's like only for the top 10% of students. Yeah, some of those kids will, but some of you guys will too. Honestly, If you compare you guys to them, sometimes you guys are smarter than them, even though they're 2 grades above grade level. Give it a try. You literally can't go wrong. So like your confidence shouldn't be like shot. Like literally just go, write down stuff.
Oh my gosh, guys, we finally understand.
I know. My bad. My bad. I'm sorry.
Oh,
I'm interested to see what we're getting out there. Is our it's not though, it's not.
1 and then O over
yeah, I'm going wrong.
You can't go wrong.
But I am
So then you wrote down an untrue ratio, you're
1
saying.
over 1 tangent. We're like, I don't know.
Don't have fractions. Make sure you flip and multiply. If you have fractions divided by fractions. Do you have fractions divided by fractions? Or no? Anyone have an answer for this one? You're getting tan? Tan theta? Anyone else getting tan?
I'm getting really tired.
Huh? Okay. How are you guys doing it? So O over H times O over H, true? Times cosecant H over O times secant H over A. So then you would say this O and this O divide out. This H and this H divide out. Oh, this H and this H divide out. So we have O over A. Then you'd say, but that's not an appropriate answer. Is so or ka or toa or none of the above. Toa. So tan. Yes. Shh. Do you want to see it the other way just for fun or not really?
I want to see it the other way.
Okay. Okay. You can't go wrong. Okay, this is my last one. I'm going to show it. Okay, so I'm just like, I guess I'll leave sine alone. So sine squared theta is sine squared. Cosecant is 1 over sine, isn't it? And then cosecant is 1 over cosine. So that means I have 2 sines on top and 1 on bottom. So wouldn't this sine squared and this sine become a sine on top? If there's 2 sines on top and 1 on bottom, that's like dividing an x squared with an x. Doesn't it become an x on top? Do you guys see why I'm saying it's just sine on top? Because it was sine squared divided by sine. So now I have sine theta over cosine theta, which I have memorized is what? Tan of theta. Okay, that's the end of my lesson. Go ahead and start working on homework, please.